Introduction. Good morning, everyone. Please take a seat so we can get started on our professional development program for today. As most of you know, the leadership team at University Preparatory Academy High School has recently completed a school improvement plan where student achievement data indicate that our students are not meeting required proficiency levels in mathematics. Several reasons for these low proficiency levels in mathematics were investigated. The leadership team studied data relating to student attendance, parental involvement, graduation rates, and specific proficiency levels for economically disadvantaged students and determined that none of these areas were significant reasons to explain the low proficiency levels of our students in mathematics. The University Prep leadership team, therefore, concluded that improvements in mathematical instruction must be addressed. Since both teacher growth and student learning are enhanced when professional development is grounded in specific classroom practices, today we are going to examine mathematical instructional tasks in terms of their cognitive demands. These cognitive demands are the kind and level of thinking that are required of students to successfully engage in and solve mathematical tasks. Some tasks require students to perform a memorized procedure in a routine manner, while other tasks demand engagement with concepts that cause students to make purposeful connections to mathematical ideas. Experiences with all kinds of mathematical tasks will ultimately establish the student's knowledge, confidence, and application of mathematics. Opening event. 5 minutes. Before we get started defining the levels of cognitive demand of mathematical tasks and discussing the importance of these levels to student learning, let's have a celebration. Last week was Pi Day, March 14th. Surely everyone has a favorite Pi joke or story to tell. Any volunteers? We have a few of our own favorites to share with you. See attached Pi Day handout. Please pick up a piece of apple or cherry pie at the back of the room before we continue. PowerPoint presentation part 15 minutes. Let's get started defining the levels of cognitive demand of mathematical tasks and discussing the importance of these levels to student learning. Please refer to the PowerPoint presentation we have distributed. The information presented in this slideshow is based on research reported in Implementing Standards-Based Mathematics Instruction written by Mary K. Stein, Margaret Smith, Marjorie Henningsen, and Edward Silver, 2009. Slide number 1 introduces our presentation titled, Cognitive Demands of Mathematical Tasks. Slide number 2 defines cognitive demand as the kind and level of thinking required of students to successfully engage with and solve a task. Slide number 3 defines the 4 levels of cognitive demand of mathematical tasks as memorization, procedures without connections to understanding, meaning, and concepts, procedures with such connections and doing mathematics. Memorization and procedures without connections are classified as lower-level cognitive demands, while procedures with connections and doing mathematics are classified as higher-level cognitive demands. The next 4 slides illustrate how teachers can ask students to think about the relationships among different representations of fractional quantities at each of the 4 levels of cognitive demand. Slide number 4 shows the memorization level of cognitive demand for converting the fractions 1/2 and 1/4 to decimal and percent equivalents. The student has merely memorized these equivalents for such basic fractions. These represent very low-level cognitive demand for mathematical tasks. Slide number 5 shows the procedures without connections level of cognitive demand for converting the fraction 3/8 to a decimal and to a percent. The student converts 3/8 to decimal form by using the standard conversion algorithm of dividing the numerator by the denominator. Then, the student converts the decimal to a percent by using the standard conversion algorithm of moving the decimal point 2 places to the right. These represent low-level cognitive demand for mathematical tasks. Slide number 6 shows the procedures with connections level of cognitive demand for identifying the decimal and percent equivalents for the fraction 3/5. The student is asked to use a 10x10 grid to illustrate how the fraction 3/5 can represent the same shaded area as the decimal 60 and the percent 60%. Here the student makes connections among all three representations and has a pictorial representation as well. These represent higher level cognitive demand for mathematical tasks. Slide number 7 shows the doing mathematics level of cognitive demand where students are asked to explore the relationships among the various ways of representing fractional quantities. The student is asked to shade 6 squares in a 4x10 grid and then to express the shaded area as a fraction, decimal, and percent. Here the student must determine how 6 squares relate to the total number of squares in the grid. These require complex thinking and represent very high-level cognitive demand for. Slide number 8 indicates one possible student response to the doing mathematics tasks. Here the student determines that 6 shaded squares out of 40 total squares in the grid can be represented by the fraction 6/40, which reduces to 3/20. Next, the student determines that each column of 4 squares on the grid represents 10 since there are a total of 10 columns. 4 shaded squares are 10 and 2 additional shaded squares are half of 10. Therefore, 6 shaded squares are 10 plus 0.5 equals 15, the correct decimal representation. Finally, the student determines that each column of 4 squares on the grid represents 10% since there are a total of 10 columns. 4 shaded squares are 10% and 2 additional shaded squares are half of 10%. Therefore, 6 shaded squares are 10% plus 5% equals 15%, the correct percentage representation. Main learning event, 15 minutes. Now that we have discussed the 4 levels of cognitive demand for mathematical tasks and have seen examples of each level for finding the fractional, decimal, and percent representations for various quantities, let's take a look at 2 mathematical tasks where finding the area of a rectangle is required. Please refer to the area tasks handout we have distributed. The carpeting task asks students to determine the amount of carpeting needed for a living room floor. The fencing task asks students to determine the dimensions of a rectangular pen enclosing a maximum space. Please take a few minutes to solve the tasks and to discuss your methods of solving them with others at your table. Now that you have solved the tasks and discussed your methodologies, let's review your results. Both tasks need students to recall the formula for the area of a rectangle. The carpeting task, however, requires lower-level cognitive demand because a memorized formula is recalled and simple substitution and multiplication give the desired result. The fencing task, on the other hand, requires higher-level cognitive demand because students must realize several different rectangular enclosures are possible. It is the rectangle of maximum area they must determine. As shown in the area tasks handout, students might 1. Draw many possible rectangles on grid paper and choose the one with largest area, or 2. Construct a table of possible lengths, widths, and areas to make the correct choice of largest area, or 3. Graph possible solutions looking for the maximum value of a parabola. The 2 mathematical tasks have basic similarities and very significant cognitive demand differences. The tasks both are area problems requiring prior knowledge of area and its formula. The tasks differ, however, in the amount of thinking and reasoning required and the number of ways the task can be solved. We hope these example area tasks have helped you to further understand the different levels of cognitive demand for mathematical tasks. PowerPoint presentation Part B. 15 minutes. Let's return to our PowerPoint presentation. Please refer back to your PowerPoint presentation handout as we continue. We will now present key characteristics of low-level and high-level cognitive demands of mathematical tasks and present factors associated with decreasing and increasing high-level cognitive demands of mathematical tasks. Slide number 9 lists key characteristics of low-level cognitive demands of mathematical tasks. Low-level demands involve recall or memory of facts and formulas and ask for exact reproduction of previously seen material. Slide number 10 lists key characteristics of high-level cognitive demands of mathematical tasks. High-level demands focus on developing deeper understanding of mathematical concepts and using multiple representations to develop student understanding. Slide number 11 lists factors associated with decreasing high-level cognitive demands of mathematical tasks. Slide number 12 lists factors associated with increasing high-level cognitive demands of mathematical tasks. Finally, please read what several educational researchers have to say about the importance of high-level cognitive demands for mathematical tasks in slides number 13-16. Slide number 17 lists all references to materials used and presented in today's professional development program. Closing event, 10 minutes. To conclude today's professional development program on the importance of high-level cognitive demands for mathematical tasks, we have several questions we would like to pose to stimulate group discussions. See attached discussion questions handout. Thank you for your attention and contributions to today's program. We hope you have learned an effective way to stimulate and improve your students' understanding and appreciation of mathematics.